Now that we understand interval notation, we can learn how to solve a simple linear inequality. A simple linear inequality contains one inequality sign. So if you look at example 4, A and B, those are examples of simple linear inequalities. We still have the variable raised to the power of 1, but instead of an equals, we have an inequality sign. To solve, isolate x. That's exactly what we did to solve a linear equation. However, there's one catch we have to watch out for when we're solving an inequality as opposed to an equation. Here's what it is. Remember to reverse, you can say flip, switch, the inequality sign when multiplying or dividing by a negative number. To understand why we do this, let's take a look at a number line. On the number line, we can tell the relationship between two numbers based on their relative positions. So, for example, I could make the observation that 1 is less than 3. This is true because the number 1 on the number line is left of the number 3. So that makes that a true statement. Now, if I look at my inequality and I decide to multiply both sides by a -1, like so, well, watch what happens on the number line. On the other side of 0, those numbers switch positions. -1 is not left of -3, so that's a false statement. -3 is left of -1. When we reflect +1 and +3 across 0 to the other side of the number line, they switch positions. So for that reason, when we multiply or divide, we have to reverse the direction of this inequality. So it would be true to say -1 is greater than -3. That's the only difference in solving a linear inequality from solving a linear equation. And also keep in mind, we're going to express the solution in interval notation. So on example 4, we want to solve the following linear inequalities. Graph the solution on a number line and then express it in interval notation. So we have the inequality 3x plus 5 is less than x minus 19. Just like we did with equations, my goal is to collect the variables on the left side and the constants on the right side. So I'm going to go ahead and subtract x from both sides. That's going to move all the variables to the left. And let's move constants to the right by subtracting 5 from both sides. When we combine like terms, we end up with 2x is less than -24. So to solve for x, we're going to divide both sides by 2. Notice I'm dividing by a positive number. I do have a negative right here, but I'm not applying a negative to both sides. So in that case, it is not necessary to reverse the inequality sign. Only when I'm multiplying or dividing by a negative would I do that. So we end up with the apparent solution, x is less than -12. If we wanted to get fancy and dress this up and put it in set builder notation, we could write it as the set of all x such that x is less than -12. But our ultimate goal here is to learn interval notation. One thing that can be tremendously helpful with interval notation is first graphing the solution on a number line. So the most important solution or number here to our solution is -12. So I'm going to put -12 on the number line, and then so we can figure out where we're oriented on the number line, let's get a few more numbers on the number line. Now our goal is to express all the numbers less than -12. First of all, notice we have a strict inequality. So at -12, we're going to use an open circle. And then I'm going to shade the numbers less than -12 or left of -12. Then we can convert that graph into two concise pieces of information. The leftmost value used, and again, because it's open there on the left side, continuing towards -infinity, we'll say -infinity is the left side, and we always use parentheses with infinity. And our rightmost value here is -12. But because we have an open circle there, a strict inequality, we'll also use parentheses. So the solution to our inequality in interval notation would be negative infinity to negative 12. What that means is I can choose any number in that interval, plug it into the original inequality, and see a true statement. Negative 12 is not included in the solution set. That's communicated both by the open circle and the parenthesis. If I plug negative 12 into the original equation, both sides would be equal, and that violates the strict inequality. So negative infinity to negative 12 would be our solution in interval notation. Let's take a look at our next example. The next example is a linear inequality, but it does contain fractions. So just like we did with our linear equations, we can get rid of those fractions. And we do that by applying the LCD to both sides. In this case, the LCD is 5. And remember, when we're dealing with a binomial in the numerator, it's always helpful to group that in parentheses at the beginning of the problem. So we're going to distribute 5 over 1 to each of those fractions on the left side. And then I'm going to multiply the right side also by the LCD. I'm not going to write it over 1 because the right side doesn't have a fraction. So again, what you can see here is all of the original terms of the inequality in green, and you can see every term got multiplied by the same LCD, which is 5. Then we can go back and cancel where we can. Observe that clears all of the denominators, which was our point, right? Okay, looking at our first product here to simplify. Now in this case, because there's no multiplier other than 1 left over, we can go ahead and drop those parentheses. Didn't cause any harm in this case. The next term would be minus W less than negative 40. On the left side, we've got a couple of like terms to combine. We could call that 12 minus 8W less than negative 40. Let's move our constant to the right side. So I'm going to subtract 12 from both sides. That's going to give us negative 8W less than negative 52. Now pay close attention here. To isolate the variable, we're going to divide both sides by the variable's coefficient, which is negative 8. Observe, we are applying a negative to both sides. So that's the case where we need to reverse the direction of the inequality. And y'all, I'm going to circle it because I will think about it and then ultimately forget to do it. So if I circle the inequality, that reminds me on the next step to reverse the direction of the inequality. Then we have negative 52 divided by negative 8. The common factor there is negative 4. So 52 divided by 4 gives me 13. 8 divided by 4 gives me 2. And of course, negative divided by negative is a positive. So we get W is greater than 13 over 2. So let's express the solution in its various forms. W greater than 13 over 2 is the solution. So again, if we want to make it fancy and put it in set builder notation, we'd say the set of all W such that W is greater than 13 over 2. Let's visualize this solution on a number line. Now to figure out where we are on the number line, I'm going to think of 13.2 as or 13 divided by 2 as a decimal. That would be about 6.5. So between 6 and 7, get a few numbers here for orientation. We have the number 6.5, but I'm going to write it as the improper fraction 13 over 2. Because we are dealing with a strict inequality, greater than, we'll have an open circle at 13 over 2, and we want numbers greater than 13 over 2, or to the right of 13 over 2. So condensing our graph into interval notation, our leftmost value there is 13 over 2, and because we have an open circle or a strict inequality, we'll use a parenthesis. The rightmost value is positive infinity, which also gets a parenthesis. So any number greater than 13 over 2, or in the interval 13 over 2 to infinity, would be a solution to that inequality. To finish up this video, let's take a look at one application. Under what circumstances might you have to think about solving an inequality? So here's an example of budgeting. Maybe you found yourself in this situation before. Colin and Reem went to Cancun for a week. They wanted to rent a car and go see all the cool sights down there, so they looked at two different rental car companies. Company A charges $40 per week plus 30 cents a mile, and Company B charges $200 per week plus 5 cents a mile. So they've got to make a decision, which company are they going to rent a car from? And of course, they want to keep on budget for their vacation, so they want the cheapest one possible. So let's look at Company A. Company A charges $40 per week and 30 cents per mile. And then Company B charges $200 per week. That doesn't sound so good. But only 5 cents per mile. That sounds pretty good. So Company A is attractive because of their low weekly rate. Company B is attractive because of their lower cost per mile. So the question becomes, how many miles must they drive in order for the price of Company A to be less than the price of Company B? Now, because Company A charges 30 cents per mile, we can imagine that the fewer miles they drive, Company A is probably going to be the way to go. But if they have to drive hundreds of miles, Company B is probably going to be the way to go. So let's figure this out mathematically. Exactly how many miles must they drive for A to be less than B? We don't know how many miles, so let's define our variable to represent exactly that. Let X be number of miles they plan to drive. So they're scoping out all the sites they want to see, and they're calculating distances, and they can approximate what their mileage is going to be. Now, let's write our model for the problem. Remember, this is one of the hardest parts of solving word problems, is the translation point from the real-life situation into mathematics. So our goal is to make the price that Company A charges be less than the price of Company B. So we got to figure out, how do I calculate the cost of Company A? So looking at Company A, there's going to be a flat fee of $40 per week whether or not they drive anywhere. So we know $40 will be part of the charge, plus 30 cents per mile. So we're going to take 30 cents and multiply it by the number of miles that they drive. But we got to be careful here. The quote is 30 cents, but 40 is in dollars, so we want to write this as 0.30 times x, not 30 times x. If we did 30 times x, that would be $30 per mile. We want to make sure we get 30 cents per mile. Let's do something similar for Company B. Company B charges the flat fee of $200 per week plus 5 cents per mile, so that's going to be 0.05 times the number of miles driven. Now that we have our model written, which is the hard part, the easy part is simply to solve it. So I'm going to collect variable terms on one side. We'll do that by subtracting 0.05x from both sides. And let's collect constants on the right side. And we can do that by subtracting 40 from both sides. When we simplify, we end up with 0.25x is less than 160. And we'll divide both sides by the variable's coefficient, 0.25. You can type 160 divided by 0.25 into your calculator, and you would see it's equal to 640. So as we suspected, the fewer miles they drive, Company A is going to be attractive. The further they have to go, Company B will be better. But now we know specifically where's that critical change. It's at 640 miles. As soon as they hit 640 miles, the values that both companies charge would be the same. If they go more than 640 miles, company B would be cheaper. So to answer the question, we can say they must travel less than 640 miles for company A to be cheaper. So if you're comparing, let's say, phone companies or landscaping service companies, you might have to think of an inequality in situations like that.